All right. So with today's warm-up, I will let you solve it whichever method you want, substitution or elimination or one of those two. Okay? Go for it. Give you a few minutes to do. These problems take a little time, so I get it. So it'll be like 5 minutes. Again, doesn't matter which method you choose, should get the same answer. Anybody have a preference as to how I show it? Elimination. Okay. Which variable did you choose to eliminate? Y's. Okay. So if I'm going to eliminate y, I could just add 1 and 2. So then that would be x minus y plus 2z equals negative 3. 2x plus y minus z equals 0. Add those two together. That gives me 3x plus z equals negative 3. Then I could do 2 times number 2 plus number 3. So 2 times number 2 would be 4x plus 2y minus 2z equals 0. 4, 2, negative 2, 0. Yep. And then x minus 2y plus 3z equals negative 7. 5x, nothing, plus z equals negative 7. I could multiply this equation or this equation by negative 1, doesn't matter. So let's go 3x plus z equals negative 3. And we'll go with negative 5x minus z equals 7. That's going to give us negative 2x equals 4. Divide both sides by negative 2. And that gives me x equals negative 2. Let's go back into this one. 3 times negative 2 plus z equals negative 3. 2 times negative 2 is negative 6 plus z equals negative 3. Add 6 to both sides. Z equals positive 3. We got x, we got z. Let's go into number 2. 2 times whatever my x is plus y minus my z is going to be 0. So x is negative 2, z is 3. Negative 4. Oops, that's right, that's purple. I want purple. Negative 4 plus y minus 3 equals 0. That gives me y minus 7 equals 0. That gives me y equals 7. And 7 sides. Quick check. Negative 2 minus 7 is negative 9. Plus 2 times 3, negative 2 times 3 is 6. Negative 9 plus 6 is negative 3. Checks out in the first one. 2 times negative 2 is negative 4. Plus y is positive 3. Minus 3 is 0. Checks out in the second one. Negative 2 is negative 2. 2 times 7 is 14. Negative 2 minus 14 is negative 16. 3 times 3 is 9. Negative 16 plus 9 is negative 7. Checks out in that one, so it checks out in all three. So my final answer then would be, whoa. Apparently, old Ben has decided to act up today. Negative 2, comma 7, comma 3. Yes? Well, today we're going to totally shift gears. Okay? We are going to go away from solving systems of equations for today and tomorrow in order to come up with a fourth method of solving systems of equations. And that is going to be using things called matrices. Okay? So today we're going to learn some basic matrix operations. Then tomorrow we'll learn all about multiplying two matrices together. Then Friday we'll be taking a quiz. Then next week, Monday, we'll get into determinants and inverses, so that Wednesday and Thursday of next week we can talk about solving systems of equations with matrices. Okay. So before we start, I will tell you, and kind of as a Wausau West brag here a little bit, that a matrix is, actually we'll tap the brakes. Let me wait on that for a second. We'll get to the brag here in a minute. A matrix is a rectangular arrangement of numbers that are organized into rows and columns. Okay? So that's what a matrix is. Now we'll go with the brag. Okay? So where you see a lot of matrices is, like for instance, at the Youth World Olympics, or the Youth Olympics going on right now in South Korea, here we've got basically this is a matrix for the games that they played, the matches that they won, and the matches that they lost. Now I say this because old Team USA right here is composed of Wausau West's own Ella Wendling and is coached by Wausau West math teacher, Mr. Wendling. So, and they are in the semifinals right now of the Youth Olympics, or the Winter Youth Olympic Games is what it's called. And so that's one real world documentation for the use of a matrix. Huh? Matrices is the plural of a matrix. Matrices are named with capital letters. Okay? So capital A would be a matrix, capital B would be a matrix, and so on and so forth. And the individual numbers that make up the matrix are called elements. Okay? So they're named with capital letters, and the individual elements are called, the individual numbers are called elements. Okay? Now, a couple of things about a matrix. Matrices are bracketed. Okay? So you have the brackets, not parentheses. If you put parentheses around your matrix, I will, and Mr. Roth will, mark it wrong, because they are brackets. Parentheses means something different, okay, in the math rule. So you need to have brackets for one. Then each matrix will have a row, or a certain amount of rows, and a certain amount of columns. Okay? So we can tell the size of a matrix if we put that right as a subscript after the capital letter name of a matrix. Okay? So the size is always going to be, and everything that happens with matrices is always rows by columns. Okay? Everything about a matrix is rows by columns. Okay? So the size or the dimensions of this matrix is 2 by 3 because there are 2 rows and 3 columns. Okay? Each individual element also has a specific address so that you know where to find it within the matrix. Okay? So just like you have a different address than I have than the house that I live at, the 3 has a different address than the -5. Okay? And so how we say this is that this 3 is living at row 1, column 1. Everything in a matrix is rows by columns. Can't stress that enough. Rows by columns, rows by columns, rows by columns. Okay? Okay? We can add and subtract matrices. We will do some scalar multiplication of matrices today. Tomorrow we will do matrix multiplication, which is more complicated. Okay? But in order to add or subtract for today, they must have equal dimensions. If they do not have the same dimensions, if the matrix that you are adding another matrix to, or matrices, because we could have 3 or 4 different matrices all being added together. If those matrices are not of the same size, you cannot do the problem and you are done. That's the nice part about matrices. If it doesn't work, you're done right from the start. Okay? So the first thing that you should do, you should look at the dimensions. What are the dimensions of this matrix? This first one. The 2 by 2. It's got 2 rows and 2 columns. So it is a 2 by 2 matrix. Okay? Dimensions of the second matrix. What you got me? It's also a 2 by 2. It also has 2 rows and 2 columns. So it is also a 2 by 2. If those 2 are the same, you can continue. If those 2 are different, you're done with that problem. And you can move on with your life. Okay? Okay? So if they are the same, which in this case they are, then we simply add or subtract the corresponding elements. So your resulting matrix is also going to be a 2 by 2 matrix. So it's going to have 2 rows and 2 columns. In the first row, first column, you're going to add the 4 to the 2. In the second row, first row, second column, you're going to add the 0 to the 7, or subtract it, or a subtraction problem. In the second row, first column, you're going to add those 2 elements together. And lastly, in the second row, second column, you're going to add those 2 together. so that we end up with a 2 by 2 matrix. And how we read matrices is we read them like a book. We read them left to right, pause after the first row, then read them left to right, pause after the next row, and rinse, lather, and repeat that process until we're all through the matrices. So this matrix would be the 2 by 2 matrix 6, 7, negative 7, negative 3. And we put brackets around. Okay. We add or subtract the corresponding elements. Okay. Okay. You now try example number 2. So we should have 3 minus negative 3, negative 5 minus 0, 10 minus negative 2, and negative 4 minus 4. Both are 2 by 2 matrices, so they both work. So that should be the 2 by 2 matrix of 6, negative 5, 12, and negative 8. Yes? No? Maybe? Okay. Love it. Okay. NTC 1 loves matrices. Okay. There's been multiple matrix questions on the final as long as I've taught this class. Okay. So that's 1. They love matrices. 2, they love this kind of problem. They love to give you this and say, find the necessary value of x and y to make this equation true. Well, you know that in order x is down here in this position, so it's got to be added to this, and we should get that. So this is going to be x plus 7 has to equal negative 2. So if I solve that equation, that will tell me what x gets. So if I subtract 7, and then you would get x equals negative 9. If x is negative 9, that part is a true statement. Y is in this position here, so it's going to be 6 plus 1. 1 plus 6 has to be y, so 7 has to be y. If y is 7 and x is negative 9, then that matrix equation is true. And then you could also check the other one. Negative 2 plus negative 3 is negative 5. Negative 5 plus 4 is negative 1. So it would be a true statement all around given those two values. Classic NTC problem. Right there. By the way, this is a true fact that if you bang your head against the wall, then you'll burn 150 calories an hour. True statement. Don't recommend it, but it is a true statement. Okay? The next topic that we need to talk about is something called scalar multiplication. Scalar multiplication is where you multiply an entire matrix by a particular number. Okay? It is very much identical to the distributive property. If you had something like this, if you had 3 times the quantity x minus 4, you would take this 3 and you would distribute it into all of the parts of what is inside that parentheses. Okay? We've done that for years and years and years. Now, with matrices, you are going to be doing the same thing. You are going to be taking this outside number and you are going to be multiplying it in to every single element inside the matrix brackets. Okay? You multiply it into all of them. Not one of them, all of them. Okay? So then this resulting 2 by 2 matrix, it won't change the size. Negative 3 times 3 is negative 9. Negative 3 times negative 2 is 6. Negative 3 times 1 is negative 3. Negative 3 times 10 is 30. Sometimes you get taken to the next level. Again, these would be classic NTC type problems. I think you can handle this one. It's a combination of scalar multiplication and adding and subtracting. Go for it. Give it a try. So first you have to do the scalar multiplication of the first matrix. So that becomes the 2 by 2 matrix 8, 12, negative 4, and 20. Then you have to subtract off the other matrix that was given. 8 minus 6 is 2. 12 minus negative 4 is positive 16. Negative 4 minus 1 is negative 5. And 20 minus 5 is 15. So we're good there. And that would be our answer. Try that one. We'll add fractions into the mix. So if I distribute in 1/4, luckily you have a nice math teacher that said, oh, let's make them all multiples of 4. 1/4 times 8 is 2. 1/4 times negative 12 is negative 3. 1/4 times 0 is 0. 1/4 times 4 is 1. So that becomes my first matrix. Then we can distribute in this positive 2. Now, I will tell you that if this were minus 2 times that matrix, you have to make a choice. Okay? And that choice that you have to make is if you distribute in the negative 2, then it becomes adding those two matrices together. If you distribute in just the 2, then it still is a subtraction of those matrices, just so you know. Okay? Okay? So then this would be plus, that would be negative 6, that would be 14, that would be 2, and that would be negative 4. So then 2 plus negative 6 is going to be negative 4. Negative 3 plus 14 is going to be 11. 0 plus 2 is going to be 2. 1 plus negative 4 is going to be negative 3. So we end up with the 2 by 2 matrix, negative 4, 11, 2, negative 3. Huh? Good times. Oh, this truly is NTC's jam, because now it's adding scalar multiplication and then finding values and all that fun stuff. Done the same way. What do you got? Joy. Oh, it is joyous, yes. Mm-hmm.
Now I see whether it's the power.
Banging your head against the wall, yeah, okay. So X is in that position, so that means I'm looking at row 1, column 1, got nothing else there, this one, and I got this one too. Okay? So this is really going to be 3/4 times negative 4 plus 3 equals X. Okay? we do realize that we are in high school, right? Okay. I just want to make sure. Because it's seeming like we're not. Just in those 4 seats right there. Okay. Oh yeah, I'm roping you in. You're guilty by association too. Oh yeah, big time. So I get X is going to be 0. Would you agree with me on that? X is 0. Because 3/4 times -4 is -3. -3 plus 3 is 0. So if X is 0, that works out. Okay. Y is in this second row, second column case. It's still being controlled by the 3/4. We have to add that to -4, and that result then is going to be 5. So that's really 3/4 y minus 4 is 5. We can add 4 to both sides. That would give us 3/4 y equals 9. We could multiply both sides by 4/3. And that would then give us y equals 12. If y is 12, then, and x is 0, then that is a true matrix equation. Questions, comments, concerns, clarifications from anything from today? Yes, sir.
Can you have like the first matrix have like 3 rows?
The matrices can be any size.
Yeah, but like one has 3 and then you're adding it to one that has 2.
No, because the dimensions have to be the same. Yep. Yep. Tomorrow, when we get to matrix multiplication, that's a whole different story. But for adding and subtracting, the matrices have to be of the same dimension.